round of applause for Rebecca.
Thank you. Hello, everybody. So I want to talk about enabling business agility. We're going to focus on the purpose, like we just talked about, because we don't want to do evolutionary architecture just for its own sake. We want to do it to achieve something, and that thing that we need to achieve is business agility. So what is this agility anyway? And I'm going to go through this relatively quickly because our keynote speakers yesterday covered a lot of this. But we want this virtuous cycle. We want to be able to have lots of different people in our organization say, I've got this great idea. We want to turn that into an experiment, a testable hypothesis. How many of you have worked on projects or programs where they say, we want to improve productivity? What does that mean? What level of productivity? Is it a headcount reduction? Is it a cycle time reduction? What does it mean? We want a testable hypothesis. We want to understand what we need to measure to know. And then we want to think about this experimental design concept. How are we going to set up this experiment to learn from whatever our user base is, whether it's an end customer or maybe it's our call center employees? Those are all users. Those are all customers. We are going to be experimenting on them. And yes, I know that's a terrifying thought in some ways. The next is fast, reliable delivery. We want these experiments to be small. We don't want to say, in 18 months' time, we might figure this out, because we don't have 18 months. And most importantly, we need to measure these results so that we can go back and I would love to, at some point, see someone do the research to add up, even for just one organization, the sum of all the cost savings that should have been accrued on the basis of all the business cases that were submitted to justify all of the projects that happened in those organizations. The numbers would be staggering. But you know, normally we don't measure the results. One of the things I loved about the conversation that started after the continuous delivery book was published was the question, do we need to redefine done? Done is no longer signed off internally. Done is in production, producing the results that were expected. That's a radical redefinition of done, but it's getting at what we're trying to do. We did this for a reason. We made this change to achieve some outcome. Did we do it or not? And then, of course, repeat. This is what business agility is all about. We want to be able to try all of these different experiments coming from all of these different places so that we might uncover that gem that is going to allow us to completely differentiate ourselves from our competition. Hopefully, this is a question that does not need answering. Why should you care about this? But in case you do, business model lifetimes are shrinking. It used to be that something as fundamental as the business model was relatively stable and we were innovating around the edges. And that's not true anymore. We have fundamentally different ways organizations are making money and competing. And those lifetimes are shrinking. And if it takes you 3 years to implement a new business model, that business model might actually be on its way out by the time you're ready. And the expectations for the pace of change are increasing. I had a reporter ask me about a year ago, tell me what technology is going to look like in 10 years. And I just laughed at him, because it wasn't that long after the 10-year anniversary of the iPhone. Now think about how the iPhone has so radically changed things. Another indicator. My colleague Neil Ford, when we give talks like this, he often asks the audience a question, and I'm going to steal it from him. I will bet anybody in this room 5,000 rupees if you can guarantee to me what JavaScript framework you will be using in 2 years' time. Anyone want to take me up on it? You can't. It has not been invented yet. And that is the problem. When I started in this business all this time ago, you could actually credibly put out a 5-year technology roadmap. You could even speculate on a 10-year technology roadmap. You can't do that anymore. Another reason evolutionary architecture has become more important is with all of this agile stuff, we've actually gotten pretty good at dealing with requirements change, but we've got a different kind of change that's coming to us with the way the technology ecosystem is evolving. Even if you don't use technology like Docker right now, you need to be thinking about your technology choices differently just because Docker exists. And we don't think about it that way. One of the things I loved about the internet giants was they actually had enough clout in the technology industry to convince everybody that not all data was relational. For years, if you were going to persist something, it was going to be in a relational database, because that's what you did with data. You put it in a relational database. And it took the giants to actually start to say, you know, there's different kind of data out there. And maybe we don't always need all of the strong transactional guarantees that a relational database gives us. But that was a fundamental change in our ecosystem. And this gets back to the basic challenge that architects have. And so many architects that I talk to, they're still being asked, where's my 5-year technology roadmap? And where's my 10-year plan? How is this kind of long-term planning possible when we have no idea when the next Docker is going to come along, or how things are going to change, or when all of a sudden something is going to hit us like Twitter or the iPhone, and suddenly all of your call center employees, not even your end customers, your call center employees are demanding better user experience that matches what they get from the next nascent internet giant. How is this planning possible? How can we maintain this dynamic equilibrium? Because that's what we have to do. We have to figure out how we can continue to deliver value to our organizations when we have all of this environmental change happening in the expectations of our users and all of this churn in the technology that underpins the systems that we're delivering. How can we do all that? And that's what hopefully I will give you some insight into. So the first thing is you have to be able to change quickly yet safely. I'm going to say it again, quickly yet safely. And both are possible. We need to have true visibility into the progress that we're making and the way systems are performing. And I don't just mean the performance metrics. I mean how our end users are responding. What are the business performance metrics? Are we getting the sales, the conversions that we're looking for? But also, are we getting the cycle time reduction or the call time reduction in our call center? Do we know how our systems are actually performing? And we need a healthy experimental mindset. And I have another piece of bad news for you. If you know how it's going to turn out, it is not an experiment. And therefore, if your culture does not accept some form of failure, you do not have an experimental culture. You cannot run an experiment if you know ahead of time it's going to succeed. That's not an experiment. You are trying to learn something. And culturally, so many of our organizations, they may talk about innovation and we want to try new things. No, they don't. They're not ready. Because they have to, as an organization, be able to distinguish from a really good idea that just didn't turn out very well to someone who had a really bad idea in the first place. And organizations, rather than trying to figure that out, which is hard, they're just going to say, every idea that fails was bad. Well, that is not an experimental culture. That is not the right mindset. And we need to rely on evidence, not speculation. We had to speculate when it would take 2 years to get something out. We don't have to do that anymore. But we also can't speculate in the way we used to be able to because things are changing so rapidly. I feel very sorry for people in positions, very often enterprise architects in quotes, who are being judged on the actual reuse of components that they are required to create without any contact with the delivery teams that might actually be using them. How are they supposed to do that? How are they supposed to know if they don't have that level of interaction with the people who are actually trying to deliver software? So we want to be able to rely on evidence from our delivery teams, from our internal users, from our actual external customers. Rely on evidence, not guesses. So that brings us to evolutionary architecture. And so first, when you're bringing out something like this, you have to first, and then of definition. I want to mention first the definition, and then I'll talk about the components in the name. So an evolutionary architecture supports guided incremental change across multiple dimensions. And all three of those aspects of the definition are important, and we debated them. But first, why the name? Neil and I, in particular, have been talking about this for a long time. And the first time I heard him speak about this topic, he actually called it emergent architecture. And he and I had a very robust conversation about how that was a really bad name. Because what does emergent imply? It kind of implies you're doing whatever just to survive. I'm perfectly comfortable with talking about emergent design. Because even though we might program in different languages and such, fundamentally, we all have the same definition of what constitutes clean code. We know when something is a train wreck. We know when something's too complicated. We would all agree on that. But there is no such thing as one good architecture. Let me give you a couple of examples. I worked on a trading system many years ago. Now, you all hear trading system. What do you think about? High throughput, low latency. This organization, in their wildest dreams, figured they would do 200 transactions a day. Not an hour, not a minute, a day. It was a trading platform. They didn't care about latency. They cared about never losing a message, because each one of those trades was worth millions and millions of dollars 20 years ago. What constitutes a good architecture in that case has a whole lot more to do with your communication infrastructure than it does to do with your individual performance. Another example, at that same organization in central London, they had a sandwich ordering system. So you could every day order a sandwich and it would magically appear on your desk, and that was one of the perks. They didn't care about security. There were no credit cards in there. It was a free lunch. They didn't care about resilience. It's central London. If the system is not available, you walk downstairs, you walk out on the street, and there are hundreds of sandwich shops very close by. The architectural requirements for that system were completely different. One final example, an organization, again, that I worked with in the UK. They really wanted a centralized architecture. They had the mothership home office and multiple remote branches. And so we came to them with an initial architectural proposal. And this was their reply, and I quote, "But what happens when we lose Scotland?" And how in the world do you lose a country? But what had happened several years ago, there had been this freak communication breakdown within their organization, and all of their locations in Scotland were completely disconnected for multiple days. And the organizational memory was so strong that they could not conceive of an architecture that didn't allow stores to run completely disconnected for multiple days. They just couldn't do it. I strongly suspect that there is no one else in this audience that has ever had the requirement of not losing Scotland as an architectural consideration. But for them, that's what constituted good. Because it would have been suicide, career suicide within that organization to create an architecture when they couldn't answer that question, but what happens when we lose Scotland? So there is no one definition of what constitutes a good architecture. There's another aspect of this that I want to talk about. People often say, well, why don't you call it adaptable architecture? It sounds so much gentler. You know, evolutionary sounds all weird and scientific and all of that. Why not adaptable? There's a very good reason for that. Most people, when they hear the word adaptable, what do they think of? Adapters. I'm going to build adapters all through my architecture so I can respond to the changes that are going to happen. Except you don't know which changes are going to happen. So you're either going to build a whole lot of adapters for things that you have no idea what's going to happen, or you're going to what? You're going to guess. I'll build this one. And then what's going to happen? The change is going to come from over here. And what have you done? You've made more code, which means you have more bugs, and it's harder to understand. And you have possibly, if not probably, made it more difficult to actually make the change you have to make because of all this infrastructure you put in anticipation of a change that did not come. And so we want to get away from this thought that you can predict these things, and that's why this evolutionary word, this evolutionary metaphor, is so important. It also feeds into this part of the definition called guided. We are going to decide very early in a project what are the key architectural drivers that are going to have the biggest influence on the success of our system. For the trading system I worked on, it was how we kept track of messages, what kind of visibility we had into the message queues and the processing that was going on for those individual messages. For all of the other kinds of trading systems, it probably has a whole lot to do with the actual performance. You know, can you get the throughput? For many people who are dealing with personal identifiable information, it's going to be security. What is the data architecture? What kind of protections do I have? You need to think about what are the main drivers that are going to determine how you design your system. And those are going to become your fitness function for your architecture. Now, as was said in the introduction, this is inspired by thinking about evolutionary computation. When we have a system like a genetic algorithm, you explicitly define a fitness function. This is what constitutes good. This is the kind of answer that I'm looking for. If it's the traveling salesman problem, what's the shortest route that I can take through all of these cities to visit all of my customers that I need to? And this evolutionary fitness function objectively captures what constitutes good. What is the result that we're looking for? Now, not surprisingly, the selection of this fitness function is critical. I listened to a talk once several years ago that was given by a group that worked for a company supporting airline manufacturers. And they were experimenting with, can we design a new airplane wing that is more aerodynamically efficient? So they loaded up as their fitness function aerodynamic efficiency and set this thing off. And they came up with this completely wild design that had all kinds of strange things poking out in multiple directions. And they showed it to the aeronautical engineers, and they all said, well, clearly, your program has a bug in it. But they ran all the calculations, and in fact, it was far more aerodynamically efficient than a standard airplane wing. much more costly to manufacture, probably would not withstand airplane flight, at least what airplanes actually encounter when they fly, but it was aerodynamically efficient. They missed a few of the things that actually mattered when you were thinking about airplane flight. So getting these fitness functions right is a big question that your team has to answer, but that's what we want. We want an architectural fitness function that characterizes what constitutes good for our system. What level of encryption do we need? What level of throughput do we need? How many simultaneous users do we need to support? What's our data retention or data destruction policy? What are those desired architectural characteristics? The single most important thing about an architectural fitness function is you and I will never disagree on whether it passes. So another all-time favorite of many enterprise architecture groups I've dealt with, the maintainable. What does that mean? You and I can have a very robust discussion on how maintainable a particular piece of code is. Instead, what's the allowed cyclomatic complexity? Fan in, fan out. Are there naming conventions? There are all kinds of ways that you can get very specific about it, what it means to be maintainable. Just like we require our users, when they give us a user story, to be very explicit about what constitutes done for a story, we have to think about architectural requirements in the same way. Here's some examples. Some of them are very simple, like static checks, cyclic dependencies. Some of them capture integration points, like consumer-driven contracts. Those were also mentioned yesterday. Maybe it's something that has a couple of our different requirements interacting with each other. So we might want to have a data staleness policy for security, but maybe we need to do some level of caching to get up to the performance that we need. And so we need to look at those two things together, because it might be the caching strategy that we're using actually violates our data staleness policy. Probably one of the most interesting versions of a fitness function is actually Netflix Simian Army, not just the Chaos Monkey. This is a continuous fitness function running all the time, looking across multiple aspects of a system. And the important thing about this is every single thing that is checked by the Simian Army is no longer on any review checklist whatsoever. You don't have to think about, are your RESTful endpoints configured properly? Because I believe it's the doctor monkey will kick you out if your endpoints are not configured properly. So you don't have to think about it anymore. You don't have to ask the question, did I do the right thing? Because your system is going to reject it. So you can focus the creativity and the time of your top technical resources on thinking about problems like, how do I get the performance I need without using this caching strategy because it violates my staleness requirement. You don't want people having to do code reviews for things like cyclic dependencies and respecting the boundaries for packages that we put in. There are static checks that can do all those, or there are online checks that can do these things. Put those things in your fitness function and then stop worrying about them, because you know that you will never have a system deployed that violates any of those constraints. Incremental change. This is a big deal in the Agile community. Within architecture, there are actually two different aspects of incremental change that we want to talk about. There is how you actually get new functionality into an application, and what are the operational mechanisms that we use to support incremental change. So one strategy for application functionality is, if you're doing something like a microservices architecture, maybe you deploy a new version, an enhanced version of a service. And you don't make anybody use the new one. You just let everybody know, hey, instead of only whole stars, the new star rating service gives you half stars as well. And then you just wait. And again, one of Netflix members of the Simian Army looks at, is anybody routing to this particular thing? And when nobody routes to it anymore, it just dissolves it out of the ecosystem. So as people gradually move to use the new rating service instead of the old one, eventually nobody's using the old one anymore. And no one has to say, gee, it's been 6 months. It's time to check to see whether anybody's using the old star rating service. It will have disappeared if nobody's using it. Incremental from an operations perspective. When I first started talking about evolutionary architecture, people would come up at the end of the talk and they would whisper, don't you think you're being professionally irresponsible to talk about changing your architecture? Your architecture is the rock, it's the foundation. How can you change your architecture? This is madness. Well, no, it's not madness. It is, however, madness if you don't do it right. And I will say that if you don't have many of the organizational disciplines in place for things like continuous delivery and deployment pipelines, you are probably taking an enormous risk trying to use something like evolutionary architecture. The deployment pipelines that we have, the continuous integration pipelines that we have, give us places to slot many of these fitness functions in, but they also, if we're using the level of infrastructure automation and control, we know what's going on. Think about what it takes operationally and from a systems perspective when you change the schema of your main database that everybody is doing integration through database even though you don't want them to be. The scope of some of the changes that we're talking about enabling are huge. And so you want to make sure that that process is as de-risked as possible. But once you have that in place, it gives you tremendous power. So what happens today in your organization when a zero-day exploit comes out for a framework that you're using? Your security department, they leap out of their chairs, they run around, they send lots of emails, they are on lots of phone calls trying to find everybody who is using this. And they can't. They're going to miss one. That's what happened to a relatively well-known credit agency in the United States. They missed one instance. So instead, if everybody in your organization had a build pipeline and your security folks had a slot, zero-day exploit, they drop something in, and all it says is, if you're running this version of this framework, break the build. Trigger a build across the entire organization. Now, the security office gets a list of everybody they have to go talk to, and you know that they've caught it all. Just like what we were talking about earlier, anything you automate, you don't have to worry about. Multiple dimensions. I've alluded to this already. Some of these architectural characteristics are incompatible. You cannot both maximize performance and encryption. It is not possible. You have to decide what you want. And you're certainly not, if you're sane, going to say, I need to maximize every one of those ilities. And that's just a sampling, but you can find that list on Wikipedia. You have to decide which ones are important to you and which ones are not. And what we're talking about is taking all of those different dimensions into account. So what are some of the principles? I'm going to talk briefly about all of these, but treat these like the Agile principles. These are things that are going to inspire you to think about doing certain things differently. For example, the last responsible moment. Delay decisions for as long as possible, but no longer. How do you know when you need to be responsible? Part of that's your architectural drivers. If it's not important to one of the key things, you can probably defer it because it's not going to have too much impact. If you have a draconian procurement department who says you can buy software only once every 15 months, then that might, again, give you a different answer, probably one you don't want. Architect and develop for evolvability. Evolvability needs to be a first-class ility. And like any of those other ilities, you might decide, actually, for this thing, if something fundamentally changes, I'm going to throw it out and start over because that's the right thing to do. But you can't probably just throw out your ERP. And so you want to think about, how do I make decisions about my architecture, and how do I do development in such a way that supports true evolvability? Pastel's law. This is how we communicate. Be very generous in what you receive. Little asterisk. Don't open up a security hole. Don't be silly that way. But if all you need is a postcode, don't validate the whole address. Why? Because if somebody changes the format of the address line portions, you're going to have to change your code when you didn't have to. Similarly, be very cautious about what you send out, because you're making a contract with people that you don't necessarily even know exist, and they are relying on things that you are making public. I'm with ThoughtWorks, I have to talk about testing. But what we have found is, if you focus on how testable a system is, you end up with much cleaner architectures. Think about, for example, the single responsibility principle. If you have to write test this and 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 this, probably that thing is doing too much, unless there is a more general term that actually describes what all of those things are. So think about what it means to actually test your system, and chances are it's going to be a whole lot easier to understand because, oh, by the way, you have all of these tests that tell you what it does. All the levels of tests. And Conway's Law. One of the things I've noticed is, if you get together a group of 5 or more people who call themselves architects, or actually do architecture even if they don't want to call themselves architects, it takes about 15 minutes before they start talking about Conway's Law, which simply says any system built by an organization will reflect the communication patterns in that organization. If you have communication silos in your organization, you are going to have integration problems. I can guarantee it. I can go into some of our clients, and when you watch the tech leads walk past each other like this, you say, that integration's broken. Don't even know what systems they are, but I can tell you they're broken, because people aren't talking. As Michael said earlier, this is primarily about people. The system stuff is a whole lot easier to keep track of. So how do we actually do this? Each one of these techniques could have a day-long, if not a week-long workshop. But I want to call out a couple. Database refactoring. If you take nothing else from this talk, there's a book called Refactoring Databases, written by Pramod Sadalog and Scott Ambler. Buy it. You cannot evolve a system if you cannot evolve the data. And they took on the critical problem of actually evolving data. Because what happens? As soon as you go live, you have data. And if you want to change that data, what do you have to do? Data migration. Sounds so simple. Copy it from this format to that format. What could possibly go wrong? It always goes wrong. This book will tell you how to make even massive data migrations much simpler to do. And that unlocks such potential in terms of being able to make your system responsive to the kind of business needs that you have. Choreography, this one's a little more controversial. Much like microservices, in certain situations, it'll give you a lot of power over orchestration, but it comes with all kinds of headaches that orchestration will solve for you. Contract testing, I won't talk about that because it was talked about yesterday, but effectively, one of the things we're trying to do with evolutionary architecture is increase the amount of work that's possible so that we can pursue all of these different experiments. And if I've got the right contract tests, Michael and I can ignore each other, do whatever it is that we want in our own systems, and even forget the other exists until one of Michael's tests breaks. And I say, uh-oh, call Michael, sorry, you're making an assumption of me that now has to change, and now we can have a conversation. Other than that, we can completely independently develop. Continuous delivery. Much like many other aspects of Agile and such, even taking small steps on the continuous delivery path will pay dividends. Get some kind of control over your infrastructure. Get the level of automation. There are lots of people who are very nervous when people like Jeff get up and say, yes, we're going to check code into production, and in 15 minutes it's going to be live. It isn't that it can or must happen. It is that it's possible, that it can happen. That you can completely automate that process. You can read the entire continuous delivery book. There's absolutely nothing in that book that says no one can, that I can't have a desk that has a big green button and nothing goes live until you hit the button. They actually talked about that yesterday, feature toggles. The stuff is out there, but nobody's going to see it. I can have my big green button, but you want to be able to do that deploy because you want to make putting things into production a business decision, not a technology decision. And they said it yesterday, but I want to say it again because this is critical. As Michael drilled into us, this is not about being agile. This is not about evolutionary architecture. This is about business agility and getting business outcomes. And you want those things to be business problems. So if I'm not lucky enough to work in a greenfield environment, how am I going to do this? Define your architectural fitness function. Figure out where you feel most exposed. Not where you think a change is going to come from, but where you feel most exposed. Start improving on that dimension. Put that fitness function into your build, but don't break it. Maybe you're worried about code complexity. So you can have your top 100 list of cyclomatic complexity. You can think about it. But you want to focus what matters most. As a former academic, I would love to say code is never ugly. There should be no ugly code anywhere on the planet. But that's not going to happen. If you've got a pile of horrible, terrible code that nobody has had to touch in 10 years, and you're hoping that if you do have to touch it, you'll just be able to throw it away, don't spend your time there. Spend your time somewhere else. Monitor, inspect, and adapt. Inspect, adapt, and repeat. Because just like the technology landscape continues to change, your architectural fitness functions may change. Your business priority may change, and therefore those fitness functions have to change. So how do we actually achieve business agility? We focus on real evolvability of the systems that we are using to deliver functionality. We keep all of our systems as ready for change as possible. We lower the cost and the risk of experimentation so we can let all of those experiments run and figure out what is really going to be successful. We're going to collect and actually use the feedback. And then we're going to get the organization all behind this. Because this really is an organizational change. Experiments will sometimes fail. That's got to be okay. People have to be willing to talk about outcomes, not implementations. That's what we need to be focused on. We need the organization to be focused on what are the organizational outcomes and objectives that we want to achieve for our end users. And that's what evolutionary architecture is all about. Thank you very much.
Thank you very much, Rebecca. I would like to invite Vinay to hand over the trophy as a note of thanks.
Thank you, Vinay.
You know, we've known each other for about 15 years now, and you just continue to inspire me, so thank you. I love hearing you speak. I love seeing you. You know, I love that you started with business agility and then kind of brought it home around business agility. We have a lot of technologists here in the room who might feel very removed from the business, right? So what can we be doing to have those critical conversations, to realize that evolutionary architecture really is a necessity to enable business agility?
Is this on? Okay, yeah. The first thing, and unfortunately this is going to be a hard message, but we have to stop talking just about technology. Just like Michael said, it's not about Agile, it's about outcomes. It's not about technology, it's about outcomes. I had a client once, a client architect come and say, I cannot convince the business to allow me to run my database recovery test. I said, well, how are you justifying it to them? Well, it's important that we understand that the recovery mechanism for the database properly and you know, on and on and on. I said, stop. He doesn't care about that. Go and tell him, how would you like to not know how long your system is going to be down on Black Friday? Because I can't tell you unless you let me run this test. And he immediately got what he needed. We have to learn to some extent to speak the language of the business. In 20 years' time, in n years' time, for some value of n greater than 1, significantly less than 100, this business technology divide is not going to be nearly as stark. But for right now, there are still a lot of people in positions of influence who really don't get technology. And so if we want to really get people focused on doing the right things, part of that is understanding how is it that the technology that you're working on either enables top-line growth, enables cost reduction, enables time to market, mitigates particular business risk. Talk about what you're doing in that context and then give them that choice. We can take 9 months to do what our competitor just rolled out, or we can start working differently and know we can't get it all because we're starting from where we are, but we can get this thing that they haven't done yet out in 6 weeks if you let me do this, this, and this. We are technologists. We're all geeks. And we love technology, but you know, the CFO really is not nearly as enamored of it as we are. And until such time as he is, or when we go to talk to the COO or the COO, and she can articulate so clearly what the future is of the business because of this enabling technology, we have to do that if we want to get it done. And so think about what's the business impact of either doing what you want to do or not doing what you don't want to do. And it's magical. You know, yes, he wanted to know how long the system might be down if something went wrong on Black Friday. Like that. Other questions? Yeah.
Thanks a lot, Rebecca. My questions is when you're dealing with, the so-called legacy application, okay? let's say a decade-old application or even 2 years, if you want to apply this evolutionary architecture for the further features that we want to develop on something which is existing, I've tried strangulation kind of a thing where, you try bother doing about this only for the new things in the new way instead of, cracking your head. But is there anything else which can help us when you're trying to apply this for the future, but on an old application?
Will have a higher probability of being relevant. You can't know for certain, but you know things like where you've made changes in the last 6 months.
Yeah.
The probability is the places that you've been changing recently are more likely to change than the things that you haven't looked at in 5 years. Focus on that and try to figure out what kind of strategies you might have to put a layer of encapsulation around the rest of it so you can move that further. Or start to focus on, do you have the right kind of separation? And maybe, you do something heretical like duplicate data. Okay, we'll let this part of the code deal with the data, but I want to start to munge it over here in a different way, so let's have the data.
Okay.
And I'm going to have a copy of the data. So, but find that. The strangler pattern, and Martin is working very hard to change it. It's the strangler fig pattern, because it's actually from a tree. That's conceptually ultimately what you have to do, but there are different ways that you can go about doing that.
So is there any reference where I can get further insights about strangler pattern?
There are a couple of blog posts out there. Martin did just rewrite that post on his site, and I think he might have some more references in there. But
thanks a lot.
okay.
Okay, thank you, Rebecca. A big round of applause for Rebecca.
Thank you.
Everyone doing today?